until this afternoon get the videos to load up for Shelby. They are going to be there shortly. I have actually pulled up some of my Tegrity videos and I've loaded them up to do them. But what I'm going to do here is we're going to look at some example problems. So I'm going to go to MyLab and Mastering and sign in. And rather than try to explain to you what limits are and how to do them, I think that probably works out pretty well on the video. I think you can understand that part because I am getting those loaded up. But the tricky part for most people is how do I use the technology to help me do this and not have to continually do this over and over and over again by hand with a calculator. You know, is there not some way to automate some of this? So that's what I want to focus on showing you right now. So what we're actually going to do, since there's plenty of video out there to explain for the class notes and plenty of videos out there to explain the Pearson homework, what I'm going to do is I'm going to go to your eText and we're going to go slow enough that you can actually follow along. I'm going to work some problems from the end of the chapter and show you how to do those problems using the calculator. Yes, ma'am. You have it in front of you right now? Doing it up in Word and doing quite a bit of this one in Word and then uploading it as a PDF. So let me show you how you would do that. If you were in the notes, what you would do, this says that you're going to be finding a limit. Let me make sure it actually opened in Word. Okay, here we go. So when you open it in Word to take your notes, then let's suppose that we're actually doing this problem right here, and I actually do this problem in the lecture notes that I posted the recording of. So what I would expect you to have handy, and this kind of plays into what I was going to do anyway, what I would expect you to do on this is we're going to find the limit of f of x equals x squared, but we're actually interested in what happens as x gets. Okay, the idea of a limit is we're letting x get close to the number we're trying to find a limit at, but we don't really care. We know that if f of x is x squared, and x was equal to 2, we know what f of 2 is. F of 2 is 2 squared, and 2 squared is 4. Okay? But in calculus, in the beginning of talking about limits, one of the ways we're going to look at limits is by building a table, and we're going to let the numbers get closer and closer to 2. So I'm going to try to give you a little explanation of what we're doing, but mostly focus on the mechanics here, not on understanding what a limit is, because we're going to talk about that a lot. The mechanics here says that you have some graph, looking at this graphically as well as numerically. The graph of f of x equals x squared is a parabola. And the number line that we're interested in looking at here is actually the x-axis, and we're interested in what happens as x gets close to 2. And of course, if x actually is 2, then f of 2 would be 2, 4. So we know that if you just plug in the number 2, 2 squared is 4. But the idea behind what we're going to try to do here, and we're going to look at this numerically, is I want to be close to 2. Okay, I just want to be very close to 2. So I'm going to start out looking from 1.9 up to 2.1. I'm going to look at that 2/10 wide interval and see what happens as 1.9 moves to 1.99 and 1.999 and 1.99999, and those numbers are going to get close to 2. So what the table is going to do when I'm doing this, maybe it'll help to see this visually, is on this big old number line up here, which is this little piece right here, this big old number line up here, I've got 2. And here's 2.1. And here is 1.9. Okay? These are to the left of 2. Everything less than 2 is to the left of it. And the way we talk about those is we're going to talk about the limit as x approaches 2 from the negative side. That means the left side. And then all the numbers on this side are bigger than 2 by a little bit. So these are on the right side. And we're going to look at the limit as x approaches but doesn't equal 2 from the right side. The positive sign indicating that I'm coming at it from the right. Numbers bigger than, numbers less than. The first number I'm going to choose, and I'm going to look at it one side at a time. I'm going to choose 1.9. Now this is not to scale, I just want you to pay attention to kind of what I'm doing. I'm going to start out at 1.9 and I'm going to find the value of f of 1.9. Then I'm going to move closer, like maybe 1.99. And from there I'm going to find f of 1.99. And then I'm going to move closer again to 1.999. And from there I will find f of 1.999. And this is all just, I'm going to use the calculator for the arithmetic. This is just the idea of what I'm doing. Don't worry about why, just what. And then from there, I can even go closer to like 1.999 or 1.9999 or 1 with 5 nines. And the more 9s I add on, the closer I'm getting to 2. So what you notice here is that if I start out here 1/10 away and I move a whole lot closer by adding a 9, what I hope to see happen is that this number might not be real close to 4, but this one should be getting closer to 4, and this one should be getting closer to 4, and the closer I move to 2, the function value should be getting closer and closer and closer to 2, which is what's actually going to be happening on the graph. Is I'm going to see that as I'm going from 1.9 and moving closer and closer, that I'm going to get a number that's closer and closer to f of 2, which is going to be 4. Now the arithmetic for this is tedious, and we don't want to sit and do arithmetic over and over again. So what I want to do today is show you how to use your calculator to do this without having to do all that arithmetic. So I will move over to the 84 if we need to. There shouldn't be any differences, but in case there are, I'll do it both ways. We're going to start out letting x be 1.9, and I'm not going to start out doing this on the, I'm well aware that I could say 1.9 squared and hit enter, and then on that table right here I could enter in 3.61. Okay, and I could continue to do that. But a more efficient way to do this, this is the way I want you to kind of learn to do it, is I want you to go to your y equals screen. And I want you to hit the clear button. Make sure all these are nice and cleaned out, that there's nothing else on Y1 or on Y anything. And the most important thing is that if you see, since some of you may have had prob and stats recently, or even in 1630 we did a little of this, if you see your plots are on up there, you have black boxes on plot 1 and plot 2, quickest way to cure that, second, Y equals, go down to number 4, plots off, enter. When you go back, they're all gone. Okay, so if you see any black boxes, second, Y equals, choose number 4, plots off, enter, enter, turns them all off. There's other ways to do it, but what I want you to understand is you're turning those black boxes off. They will cause you problems because your calculator will get confused. So what I want to do here is I want to enter f of x. F of x is x squared. Not hard, okay? Then the second thing that I want you to do is I want you to hit your second button and the window button. So we're just kind of like going across the top of the rows of the calculator. On the window button, I don't care what it says here. I don't care what it says here. What I want you to do is take your arrows and move down to where it says independent, that's the x values. And I want you to move that cursor over to ask and press enter. And I want you to leave that screen looking like that, unless I tell you differently. Just leave that screen looking like that all the time. Because we're going to do this a lot and you don't want to have to go back and change it all the time. So you want it set up to where independent says ask. I don't care what that says. I don't care what this is. Dependent needs to be auto. Independent needs to be ask. Okay? You have to be sure that you first put your equation in the y equals menu before we can do anything else. So those are your first two things just to set things up. Now here's what we're going to do. You're going to press your second and your graph button to go to your table. Okay. This is how we're going to build this table, and you're going to be amazed how quick this goes. We want 1.9, then we want 1.99, then we want 1.999, and then the next one says 1.12349s. And all we have to do then is come down here and fill in this table. Now the table may have to be bigger. I'll show you how to adjust it if you want to do it. Do this in Word. And I want you to notice something here. This number is not actually just exactly 3.996. It's actually 3.996001. Okay? And the next one is 3.99960001. So put all those decimals in there. Put your cursor in the Y column, because the problem here, the reason that you're not seeing all the digits is because that column is set up inside the calculator's memory that it can only show you 1, 2, 3, 4. It can only show you 5 numbers in a decimal. It can only show you 6 characters, okay? But it knows that in reality, if you square the number 1.9999, that's not exactly 3.9996. It's 3.99960001.
It looks like we can modify what you are. I'm sorry we're having so much trouble.
Okay, for the people that are trying to do this on the calculator or on Word, give me 1 second, and I'll let you pull up one that you can do. I'm gonna put this in everybody's folder. Let me go to Shobi. No, I didn't need a new browser, thank you. Go to section. Actually, I think the way that I want to do this, because you're going to have to use this over and over again. I'm going to go to Chapter 11 Homework Questions folder. Is my Dropbox on here? Apparently not. Okay, if you're going to the chapter 11 homework questions, you can download the Word document. And then open it just like I did. Okay? And you'll just enable the editing. It'll open up in Word for you. So that'll solve y'all's problem. So once again, notice here that even though I typed in over here 1.9999 and it gave me that answer for y, that the correct answer is actually, it's been truncated. It'll round it to as many decimals as it can show you.
Yes. Those numbers that you get on the table. How do you get these numbers from there?
You just type them in.
Just type all those numbers in?
Into the table on your calculator. This is just for quick arithmetic. We don't want to spend all our time sitting there doing lots of arithmetic when the calculator can do it for us really fast. You just need to know what its limitations are. Okay? Now, there is one more value out here. So go down in your column and go out to that one last value, and I want you to notice something that happens, so pay attention either while you're doing it or while I'm doing it. I'm going to type in the number 1.9999, and I'm going to add one more 9, 5 nines. Now remember, the calculator cannot show me more than 5 digits and a decimal. That's all it can show me. So when I hit enter, look what it tells me I just typed in. Now that's not really 1.99, that's not really 2. It knows that that's 1.99999 because I typed it in. And that's the number that it used. But it couldn't show me all of that number, so it changed it to a 2. Because that rounded off to 4 decimal places, that's what it is. But if I move over to the y equals, that wasn't exactly 4 either. That was 3.99996000001. Okay? Now all you're doing is arithmetic. the purpose of the arithmetic is you're starting out somewhere close to 2 and then moving closer and closer and closer and closer, and then observing what happened as you did that to the values of f of x. And as you moved closer, the values of f of x, 3.61 is not all that close to 4, is it? But 3.961601, well, that's quite a bit closer. 3.996001 is even closer. And by the time I come out here, and instead of 2 putting in 1 and 99,999 hundred thousandths, so 1/100,000th away from 2, I am only a very, very, very little bit away from 4. Okay? What this tells me is that x approaches 2 from the left. The value of f of x actually approaches what we already knew, which is 4. Okay? Now, everybody in here should be able to do this process. If everybody in here is confused about why we're doing this process, don't worry about it. I expect that at this point. You're not going to develop any meaning out of it for a little while. It's kind of a visual, and it's a very fuzzy concept to master. But I want you not to have to be bogged down in the math, the arithmetic, so that you can step back and actually look at the concept when we master the ways to get the numbers. Okay? Now, here's the good thing. I need to move down here and do the approach from the other side. Notice that I'm starting out 1/10 away again. So what I'm going to do is I'm going to go back over here, and the good thing is I can just type over the top of these numbers and it'll automatically change things. If I take 2.1 and square it, I get 4.41. But if I take 2.01 and square it, wrong place, sorry. I get 4.0401. And then the same thing for 2.001. And 2.123 zeros and then a 1. And then 2.1234 zeros and then a 1. And notice it did it again, even though I entered in 2 and 1/100,000th, so 2 and 1/100,000th. It gave me 4, but actually it was 4.00004000001. So while 4.441 is not terribly close to 4, when we get out of here, 4.00004000001 is very, very close to 4. That's the calculus part of it. Yes?
If you put something on your XY graph on your TI, and you want to get rid of it, like let's say you just press, I've got 2.01 X column, and I want to get rid of that.
Just type over the top of it. No, you just type over the top of it. You don't want to put a 0 because you're substituting the 0 for it. So you can put 2.1 there. 2.01. Now, there is a limitation. You can't go any further. It's going to keep repeating that last one. You can only make about 5 or 6 values in that well. Okay? That's why you saw me go back and start at the top again. Okay? Now, whether or not you understand what the limit has to do with, can everybody do the arithmetic here now? Okay? That's the hard part for me to explain to you in a video. when I can't have the calculator in front of me showing you how to do it. Sometimes I can at home, sometimes I can't. Now, when we get further down in these notes, like here, you're going to use the calculator again. It's the same exact thing. And when you do this, you're still looking for as the limit goes to 2. So you're still going to use the same set of numbers that you used before. You're going to use, let's see, what we want to do is we want to converge on 2. And I'm not going to worry about what it comes out to be. So if I want a little more than 2, I want 2.1, 2.01, 2.001, 2.0001. And then out here, I want to start out at 1.9, then step a little closer, 1.99, then a little closer again, 1.999, and then finally 1.12349. So you don't really have to go to 5 decimals on this. Because, I mean, let's face it, if you're only 1/10,000th away, that's pretty darn close to where you're trying to get. Okay? And then you're just going to use this here, and you're going to turn. Now, this is another important part. If I'm going to build this table, I have to put g of x in correctly. So you go back to your function, and g of x has to have parentheses around the numerator and the denominator. So I'm going to start out with parenthesis x raised to the 3rd power minus 2x raised to the 2nd power, or you can hit your square key, close the parentheses, hit your division symbol, and then put the denominator in parentheses, x minus 2. And then when I get ready to finish building my table of values over here, I just go second table, and I start entering in my numbers. 1.9, 1.99, 1.999, 1.9999, and then if I actually enter in 2, because that's what's next in my table, then it, oh wait, it gives me an error. Why did it give me an error when I entered in 2? Why is 2 giving me an error message? Because it's undefined. Why is it undefined? That's right. 0 cubed minus 2 times 0 squared is actually 0. 2 cubed is 8. 2 squared is 4. 8 minus 2 times 4 is 8 minus 8, and that's 0 in the numerator. And 2 minus 2 is 0 in the denominator. You're winding up with 0 over 0, and 0 is the only exception to the rule about fractions that says anything over itself is equal to 1. And the reason 0 over 0 doesn't equal 1 is because I don't care if you've got nothing, you can't divide it up into nothing. It's already nothing. Okay? You never, ever, 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 ever divide by 0. So even if the only problem was that x minus 2 is going to be 0, we don't get an answer if we plug in 2. So what we're going to have here is going to be undefined. Okay? And then I can continue starting again at 2.1, 2.01, 2.001, 2.0001, and again That's because that actually is 2. It would give me an error. At that point, I'm finished filling in my table. Okay? Now, in the video that I have posted, I do show you algebraically what went on. Because you're probably sitting there saying, wait a minute, that was the same y numbers that were in the first example. Why did they come up the same? Well, they came up the same because if you factor that expression, it turns out that that expression is equal to x squared, as long as you don't let x be 2. Okay? That is exactly the same graph as f of x equals x squared, except f of x equals x squared, you can plug in 2. This one you can't. And while we're here doing it, I'll just verify for you, and this may give you an idea of why I've got those skills problems for you to do before you actually get into the chapter. How many people remember how to factor? Just love factoring. No, I mean, I don't love it. I know how to do it. I don't like it. Okay? Well, let's factor g of x just for practice. I'm just writing it down right now, then I'll switch. Let's factor this. I see x cubed and x squared. The greatest common factor there is x squared. So x squared times x gives me x cubed minus x squared times 2 gives me 2x squared. The denominator doesn't factor. But now that I've factored it, I can take out the common factor, and that tells me that g of x is equal to x squared, except the original g of x had a restriction in its domain. X wasn't allowed to be 2. So you have to add that restriction to your function. So that's why the numbers came out to be the same. We were really looking at an equivalent form of that equation. And that's where the analyze algebraically comes in. Now, here again, this is where a word's going to fail you. Because the problem we've got here is you're not going to be able to fill in that on Word drawing lines. That's tough. Now, there's ways around it, but none of them are simple. But here's the idea of what I wanted you to find. Given that we've got this function already in the calculator, what I want to do is I want to graph it on the calculator. That's really there just for you to sketch what you see. Okay? Let's look at a graph of x cubed minus 2x squared divided by the quantity x minus 2. This time we're going to need to set the window, and the way we're going to do that is we're going to hit zoom. I want you to get comfortable using your zoom button. Zoom standard basically just gives you the graph on a window that goes from -10 to 10 on the x direction and -10 to 10 on the y direction. That's what Zoom 6 is. So, kind of think about that in your head. But I want us to look, we're focusing on what happens really, really, really close to 2. I don't want to make the window too small, but I want to make it small enough that I can see mostly what's going on right around the point 2, 4. Okay? the calculator's got a special window. If you hit zoom and you go down to number 4, which is zoom decimal, notice that I can see more of the graph, but here's the problem. If I try to find where x is equal to 2, and I'm tracing on it, I'm not able to get right on 2. Okay? Now, some of you that had me for finite and remember this a little bit might remember that there's a way that you can actually use your calculate button, which is second trace right here. There's a way you can get it to show you where x is exactly 2. If you hit second trace and choose value, the very first thing, and say where is x equal to 2, it says, well, x can be 2, but the function doesn't have a value when x is 2. Notice that the y is blank. It doesn't tell you anything. That tells you that there is what we call a hole at x equals 2 in that function. Now, in order to see that hole, because believe it or not, on the calculator, even though you shouldn't be able to, you can see it. We're going to go to the window, and this is all in the video that I've got too. But again, it's easier to show you this rather than just talk at you about this. I'm going to start, since I don't really need to see much in the negative direction, I'm going to start my graph at 0 for the x's. So let it go 0 to 4.7. You know, and 2's within, it's in between 0 and 4.7. So that'll be okay. I also really don't care too much about what goes on below the x-axis. So I'm going to come down here and I'm going to let the minimum value of y also be 0. But I remember noticing that when I graphed that and I asked it where is x equal to 2, it really couldn't show me that too well. The equation was covering it up. So I like to make the window a little taller. This is one of the handiest things I ever learned on this calculator. If you've got a window and all you want to do is make it bigger, you can multiply on your window values. I want to make this go up a little higher, like let's say times 3, because 3.1 times 3 will give me something more than 9. And 3 squared is 9, and 3 is the next number after 2, the next whole number after 2. So I'm going to multiply that by 3. And when I do that, it multiplies right there on the screen for me. So that's a good thing to know. And now I'm going to hit graph. Now, if you followed along with me, did you notice anything strange about your graph? Can you see the hole? Where do you think the hole is? It's right there at 2. Right there's the hole. Okay? So what that is telling you is that if you hit trace and you try to get closer to 2, now you fell in the hole. And if I come from the other side and I try to get closer and closer to 2, I fell in the hole. That function doesn't exist at x equals 2. And the graph's showing you that. But I want you to notice what happens, and I'm going to start at x equals 0. What happens is I get closer and closer and closer to 2. Watch y grow. Now I'm at 1.5. That's only a half a unit from 2. That's not real close to 4. Now I'm at 1.7, and I'm almost to 3. I'm at 1.9, and I'm at 3.4225. 1.9, I'm at 361. 1.95, I'm at 3.8. What's it getting closer and closer to now? 4. And the same thing if I approach from the other side. If I start out at 3 and I move going toward 2, notice that y is slowly getting smaller. Now I'm at 2.1, 2.05, but now I'm at 2 and I fell in the hole. But just before I fell in the hole, I was pretty close to 2. Now I could fiddle with the calculator window and get it to actually show you all the way down to like 1.99 and 2.01, okay? But that's not the point. You already saw that numerically. As you approach 2, even though the function g doesn't exist, there is no g of 2, but as you approach 2, g of x approaches 4, okay? I know that's foreign to you still, but it will get better, I promise.
So the G of 2 is undefined?
G of 2 is undefined, okay? Now what the rest of the video explains is when I'm approaching from 1.9 and 1.99 and 1.999, that's called taking a limit as x approaches 2 from the left. That's what you're doing when you do that arithmetic. You're taking the limit of the function as x approaches 2, and it'll have a little negative sign after the 2 to show that it's coming at it from the left. And that the value of the right-hand limit, which is as x approaches 2 from numbers bigger than 2 or positive, is also going to be 2. So what we're doing here is we're taking limits visually on a graph. We're taking them showing why those two functions were the same by factoring, and then we're actually plugging in numbers and we're looking at it numerically, saying that even though g of x is not 2 and can't be 2, we can find out pretty close to what g of x would be if I could get really, really close to 2. Okay, and that's going to be something useful later. And because this is a piecewise function, it's worth showing you how to put a piecewise function into your calculator to build a table or a graph. Okay? So let's go over to your y equals menu and let you follow along with me to do a piecewise function. Now before I actually plug it in there, I'm going to come over here and write out what you're going to want to plug in. The original function is h of x, and it has two different rules that it follows. One of them we've already been looking at. H of x is equal to x squared if x does not equal 2. So if x is numbers less than 2 or x is numbers greater than 2, then we take those numbers and square it. And we've already built tables for that same function, so we know what happens as it gets close to 2. But this function says that if it is equal to 2, then the value of h of x, in other words, h of 2, is going to be 1. Okay? It's going to be 1. So what that means this is x, this is h of x, and x is equal to 2, h of 2 is equal to 1. Ah, thank you. Thank you. Okay? So what happens as I take x and I get closer and closer and closer to 2? Well, it's exactly the same thing that happened on the calculator before. That didn't change because that's following the rule this way or So if I go 1.9, 1.99, 1.999, and 1.9999, I see the same thing happening that happened before. I get 3.61, 3.9601. We'll just go with the rounded answers here. 3.996 and then 3.9996, and then suddenly it's 1. And if I come from the other side and start at 2.1, 2.01, 2.001, 2.0001, then what I see here is that it starts out at 4.41, then it goes down to 4.0401, then 4.004, and then 4.0004. So the limit as x approaches 2, this is the way you actually write these, from the positive side for h of x, the limit is actually 4. And the limit as x approaches 2 from the left side, which is the negative side, of h of x is equal to 4, because this and this are really, really both very close to 4. But the function h of 4 is actually 1. I'm sorry, not h of 4, h of 2. h of 2 is actually 1, which doesn't match either of these. And that's going to tell us something important too as we get into this. Okay? Now, to the problem of how do I enter that function in as a piecewise, because that's the part I want you to know. First of all, you enter the first part of the rule, which is x squared. But you put the first part of the rule in parentheses. And then in parentheses after it, you enter in its restriction. And its restriction says h cannot equal 2. Okay? So if you go second math, this calculator is so hateful. If you go second math, does not equal is the second thing on there. Now I needed to put my x in, so let me do that again. X, second math, choose option 2, does not equal 2, close parentheses. Plus, then you put in the second part of the function, which is just the number 1. And it goes in, again, parentheses. But its domain is only if x equals 2. So x, second math, equals 1. Or not 1, 2. Okay? So what this is telling the calculator is this is the formula for my function. As long as x is not 2, just take the number and square it. But if x is 2, then give it the value of 1. Okay? Now if we graph it, we should see something really similar to what we saw a minute ago. Except that there's going to be not just a hole at 2, but we should see that there's a point down here at 1. So it's actually trying to show you that point right there. I mean, it's obvious where the hole is now. The reason it's trying to do this is because it's trying to come all the way up close to 2 as it can get and then dropping down to 2-1. And then it's hopping back up and trying to follow the x squared again. Now, if you don't want to see that, and I don't, then I want you to press your mode key and make sure that you're in dot mode, not connected. Now, unfortunately, my calculator still tries to show it to you. I can't get it not to. But I think the TI-84, they fixed that. So let me enter this in on the TI-84. Okay. Everybody see my TI-84 screen here? Shows you the hole, and it shows you the point. Okay? Now, one of the things that we're going to learn has to do with when is the right-hand limit and the left-hand limit, when they're the same. What does that tell you about the limit of the function, regardless of which way you come at it? And then we're also going to play into that a little bit later toward the end of the chapter, talking about continuity. That function isn't continuous at x equals 2. Neither was the previous one. Okay? I think we're coming up on done for the day. Right? So, I've got the lecture finally loaded up for 11.1. It's an actual classroom lecture that you can watch. But I'm also making some shorter ones so that you don't have to watch the whole thing and try to scroll through and find it. So they'll be up there too. Get as much of 11.1 done as you can and try to preview 11.2.
Just like the notes or the homework too?
Just the notes. If you can't do 11.2 homework, that's not a problem. And if somebody notices that the due dates in my math lab, because of the holiday and everything, that those due dates are coming up too quick, remind me and I'll go extend those out a little bit. The show me homeworks, like I said, those are kind of flexible anyway. This first chapter give you a chance to get used to all this. Okay?
The math lab homework is all like set for December.
I thought I changed them, but I may not. They will have staggered due dates like what you had in Math 1630. They'll have staggered due dates just like what we had in 1630.
Yeah.
Okay? And then all of chapter 11, including the quiz, will be due the night before the test. That's all. The Math 1630 people, I'm doing things the same way.
Used to do all the stuff on my math lab, like all the review, everything like
You don't
that.
have to do the skills review. You have to do the quiz. You don't have to do the homework.
And then we have to do all the homework and class notes on Chevy as well, right?
Yes.
So,
But the show me homework is usually not very much. It's like 5 or 6 problems. It's not like do these 30. I'll leave that stuff.
What's the first test?
I'll have to look. I had figured it out, but it's before the end of the month. Okay? So I'll look at your I'm gonna like cover one chapter on each test. Otherwise, when I get to chapter 12, chapter 12 covers just chapter 12, but then when I do 13, I probably will pick back up on some of 12 because I'll figure out some of you didn't know how to do on 12, so I'll come back and do it again.
Thursday.
You're going to do 11.1 and show me homework, and then work on your notes for 11.1 and 11.2. You need to finish 11.1's notes and you know, look at 11.2.
And what about Pearson?
Pearson, you should be able to do 11.1.
Do the homework and the quiz?
There's no quiz for 11.1,
Okay,
it's just a homework.
just homework.
But you need to do this.
If maybe do a quiz to.
Yes, that quiz though is not calculus, it's review. It's just a review. And you have to make 85% on the skills review quiz to open the homework. But if you can't, the skills review homework is there too. You don't have to do that, that's optional. It doesn't count on your grade at all. But if you do that and you can make 85% on the homework, I'll give you 85% on the quiz instead.
And that's all due before Thursday.
Yeah, because you can't do your 1.1 homework if you haven't done the skills review.
Well, I mean, like the homework and stuff is all due before.
Only through 11.1.
So Shelby, right?
Shelby and my math lab.
All of us do.
Yeah, by Thursday. But it won't be by class time Thursday, it'll be like.
Is there like 11.1 homework problems in Shelby?
Yeah. There's, I think it's 2 pages, I think there might be,
Can you show me real
6
quick on
problems.
Shelby? I'm visual and I couldn't find the lecture either on Shelby.
It wasn't there until just now, that was the problem.
Okay.
I was just now getting them loaded up.
I just wanted, I'm so visual.
This is where I'll always put the notes, and I've got to move the other
Yep.
ones into that.
Do you guys want to look at what the homework? Yeah. Oh, she's looking, okay.
Yeah, I've still got it up there so they can see too. So here's the 11-point homework folder, which I must unlock now, because I forgot to. That is the correct due date. I'm trying to give you plenty of
Yeah,
time.
perfect.
Wait, so chapter 11.1 homework's due September 12th?
I really want you to do it by next class though.
Yeah.
Just because I left it hanging out there open doesn't mean that that really is when you should do it, because we're coming up close on a test not long after that. Okay? That's like a week from tomorrow, or today, a week from
Yeah, a
today.
week from today.
And it's not gonna take you a week to do
Yeah.
that homework,
Okay, so
promise.
that's our homework on Shelby.
Okay.
We have to
Yeah.
do 11.1 and then
Right, and here's the homework. I want you to see what it actually
Yeah, that's
is.
easy.
There's 3 pages and there's no more than 3 problems on any one page.
And we'll see how to do
Okay.
that stuff in the lecture.
That shouldn't take you a week, yes, you'll see. And the thing, let's see, there's one, your turn 5, and I'll try to make a note up there. Your turn 5 is based off of example 5 in the notes. It's asking you to take the same problem and do something else with it. And I'll make a note of that in the comments there, because I didn't modify that because I forgot to. But I know that's confusing. People are like, what's f of x and g of x? So I'll tell you what they are,
Okay.
okay?
And then what folder is the lecture in? Couldn't find
The
it.
lecture will be, since I do those by sections,
Okay.
the lecture will be right here. In fact, I'll make a note here. Spelled
So the
together.
11.1.
So we need to watch the video for 11.1, do the notes, then do the Shelby homework, then do the skills check, and then chapter 11.1.
Yes.
Okay, perfect. We'll do yours. Okay. I'll probably,
Okay.
will that be up pretty soon? I only have tonight to watch it before Thursday.
Yeah, as soon as I get back to my office, it should be there. But I'm just waiting on the YouTube links to come back to
Okay,
me.
perfect. Thank
Because
you.
mine all go to YouTube,
Oh, okay.
okay?
Thank you.
Did you write everything on the mind map now that you
Hmm?
do we have to do all the homework, the 3 tests on the mind map?
Except the skills check homework. You do not have to do that. You know which one that is? It's
Yeah,
like,
that's
you know,
right.
there's a skills check quiz and there's skills check homework. You have to do the quiz, you don't have to do the homework. Okay, if you don't need it, don't do it, leave it alone.
Thank you.
You're welcome. Come by and see me if you need help.
I'm just emailing myself real quick, the notes from earlier today, and then if I can ask you a question.
Sure, I'll hang out for a little while.